Spanning Tree Protocol or STP. In this video, I am going to talk about the Spanning Tree Protocol fundamentals. You know that we are using STP or Spanning Tree Protocol for preventing loops in layer 2 network. You have learned about the STP in the CCNA class. Actually, you know that STP is a protocol that we are using it, okay, for providing redundancy in our network and preventing loops. Okay, but in ENCOR class, we should learn about multiple STP iteration or STP versions. Let me to review STP versions. STP has multiple iteration. The first and the traditional STP is 802.1d, okay, which is the original specification. The second version of STP is per VLAN STP protocol or PVST. This is a Cisco proprietary version, or the first Cisco proprietary version. After that, you know that per VLAN Spanning Tree Protocol Plus or PVST Plus created by Cisco again. Because of that, today's the PVST or the per VLAN Spanning Tree is considered expired, because actually when you are using the PVST only we can use ISL trunk links, and today's you know that in most cases we are using .1q trunk interfaces. Because of that, the PVST doesn't support in this in the Cisco switch, but PVST Plus or per VLAN Spanning Tree Plus supported by the Cisco. After that, we have the next version 802.1w Rapid Spanning Tree Protocol or RSTP, and finally 802.1s Multiple Spanning Tree Protocol or MST. Okay, actually today's in Cisco device we have three options about the STP: PVST Plus, RSTP, and also MST. Okay, we have this option in the Cisco these three options in the Cisco switches. Okay, first per VLAN STP, after that Rapid STP. Also, let me to emphasize that RSTP doesn't support in the Cisco device. Actually, we have Rapid PVST. You will learn about it, and after that we are we have the MST, okay, in Cisco switch. 802.1d is the base of the PVST Plus. Okay, actually when you are using 802.1d, okay, you have only one STP instance in your network, but with per VLAN Spanning Tree Plus or PVST Plus, you have multiple STP or multiple 802.1d instance in one network. Rapid STP is has a more speed, okay, in compared with the STP or PVST, and MST has other advantages. In the CCNA class, we have learned about the PVST Plus. Okay, we have learned about the PVST, also about the traditional STP, okay, and also about the RSTP. Okay, but in ENCOR class we are only reviewing the per VLAN STP Plus or for example RSTP. Only the MST is new in this class. Because of that, I'm going to give you a chance for reviewing the CCNA video. Because of that, first we will go to a trip to the CCNA class. In the video of CCNA that I have created before, we will learn about the 802.1d, why we need 802.1d, the rules of the 802.1d. After that, we will have the per VLAN STP Plus, and finally RSTP. But we will learn more than CCNA in this class about the MST. Because of that, let me to start the journey of this STP. Okay, actually first we should go to the CCNA video class. In this video we will learn about the need to STP, why we need to the STP. Okay, because of that, after we can learn STP step by step with the help of CCNA class, and also after that with my explanation in ENCOR class. All right, now let me to start the STP journey with going to the CCNA video class. The first things that we should know is that why we need STP. After that, we will talk about the STP itself. STP STP or spanning tree protocol. In this video, I'm going to talk about one of the most important and most famous and most useful protocols in the LAN. We call it STP. First, we should know about the function of the STP. After that, we can learn about the tuning of the STP and also some part of configuration about the STP. Let me to start talking about the STP with this scenario. In this scenario, as you can see, we have three switches, switch 1, switch 2 and switch 3, and also three PCs, PC1, PC2 and PC3. I added one link between the switch 2 and switch 3 for redundancy. Let me to remove this link. If you don't have this link, when the for example link between switch 1 and switch 2 failed, okay, this means that we don't have connectivity between the computer 2 and computer 3 and computer 1. Or if this link, for example the link between switch 1 and switch 3 is failed, this means that we don't have connectivity between the computer 3, computer 2 and computer 1. Because of that, it's a good practice and it is useful that having one link between the switch 2 and switch 3 for redundancy. Because of that, as you can see now, we have one link. This is the link that we are adding for redundancy and for fault tolerance. Okay, the reason that we are using this extra link is for fault tolerance. For example, assume that with this link, now I am removing this link, failed, assume that this is failed, and after that, because we have the link between switch 2 and switch 3, we can send traffic from this link from the computer 2 to computer 3 or computer 1. Or if the link between the switch 1 and switch 3 is failed, we can send traffic from the computer 3 with this link to the computer 2 or computer 1. Because of that, it's a good practice for that we add one link between the switch 2 and switch 3. Very good. This is the good side of the for example adding one link, but here we have one bad side effect. Let me to talk about this bad side effect. Because of that, if we should follow a packet from, for example, computer 2. After that, we can understand what is the bad side of the adding one link. Look at here. First, I'm trying to send a traffic from the computer 2 to the computer 3. You know that the source MAC of this packet is MAC2. Let me write here M2 means MAC2, and destination MAC of this frame is MAC3. Okay, this frame now is receiving by switch 2. You know that in each switch we have a MAC address table. Let me to show you MAC address table. In MAC address table, actually we have 4 fields, but let me to use only 2 of the most important fields, the MAC address, okay, and after that the for example port. And you saw the MAC address table and you know about the detail of the MAC address table. Okay, this is the MAC address table of the, for example, switch 2. Let me to write here MAC address table of the switch 2. Okay, and the MAC address table by default is empty. Because of that, when we are receiving this frame, first we should learn the MAC address of the for example M2 means MAC2 on the port 3. Okay, let me to write here. Now we have one entry here, and that is the M2 means MAC of PC2 on the port, for example 3. We can use fast Ethernet 03. Okay, after that, because we receive one unknown unicast frame, you know that this MAC address M3 is not available in the MAC address table of switch 2. Because of that, this is an unknown unicast. Unknown unicast frame should be flooded. Because of that, we should flood this frame to the switch 1 and also to the switch 3. You learned about the rules. When we are receiving unknown unicast frame, we should flood. It means we should advertising or forwarding this frame from all of the other ports except the incoming interface. Because of that, now this frame is received by switch 2. First, the source MAC is learned on the fast Ethernet 03 and then flooded. Let me to follow one of them first. Now I'm going to follow the this frame from the M2 to M3, and now this is received in in the switch 1. In switch 1, again, we have the similar MAC address table. This is the MAC address table of switch 1. Okay, here when we are receiving the frame from